So a lot of questions have come up about review and looking over again of how we calculate a equation for a line in point slope format between any 2 points. And the points I'm going to use here are 4, 6, that point right there, and 2, 1, this point right here, which I'm going to label 4, 6 as x sub 1, y sub 1, and I'm going to label 2, 1 as x sub 2, y sub 2. So we're trying to get this point slope formula of y equals ax plus k, where a is my slope and k is going to be my y-intercept. So let's first think about if I wanted to move from my x sub 1, y sub 1 point to my x sub 2, y sub 2. And let's say we can only move in a vertical or horizontal line. So let's deal with our vertical shift first, our rise, as we say. So since I have to travel down 5 units to get to this point, in our Cartesian plane, when we move up, it's a positive number. When we move in a direction that's downwards, it's considered a negative number. So in this case, our rise is actually a -5, getting from that 6 to a -1. Now let's look at how many units we take to travel horizontally. So if you see here, we're moving to the left, and in our Cartesian plane, those 2 units that we move to the left are going to be negative, because when we move to the right, in a direction of right, that's considered positive in our Cartesian plane based on the way our axis is. When we move to the left, we're going to move negative. So our run is going to be a -2. And when we consider the formula for slope, which is what we're calculating first, we do the rise over run. So we have this -5 rise over the -2 run. And when we simplify that, we get a slope of 5/2, which if we think about the slope of this line we're going to have between these 2 points, it's going to be positive. Another way to think about this is our delta, or changes in y, over our delta x. So if I take my delta of y sub 2 minus y sub 1, which in this case is 1 minus 6, over my x sub 2 minus x sub 1, my 2 minus 4, I'm going to get that -5/2 again, which simplifies to 5/2. So both methods get us the same slope. So at this point, we have figured out how to get our slope. So now what we need to do is we need to select one of the points, and you can select either point, but I've selected 2, 1 because this point needs to be on the line. Again, we have that our slope here is a 5/2, which we found here above. Now, based on this coordinate, this 2, 1, see that our x is a 2 value, and our y is a 1 value. And again, this is our formula. So based on using substitution, what I'm going to do is simply put, for my a value, 5/2. For my x value, I'm simply substituting, times 2. And for my y value, equals 1. So you see, we simply use substitution. And now we're going to solve and figure out what k is. So now we're solving for k. So what we need to do first is do our calculation of 5/2 times 2, which gives us 10/2 plus k equal to 1. If I simplify that further, I get 1 equals 5 plus k. I then subtract, or I add a -5 to both sides to isolate my k. Finally, I get a k equals -4, so I'm going to move k back over here. So now we've figured out what the slope is. We've figured out what the y-intercept is. So now what we're going to do is create our equation or our formula for our function in the slope-intercept form. So again, this is our format for our equation, where this is our slope A, and this is our y-intercept k. So all we need to do here is again substitute. So we want to substitute our A. We want to simply replace it with the A we found for our slope. Then we want to substitute, get them together. We want to substitute our k value. So we end up getting an equation of, I can type it in, y equals 5/2 x times x minus 4. And that should give us our line. So let's go and test it out. So I've gone to Desmos, and you can see I've plotted my points 4, 6, and 2, 1 that we saw in our presentation. So now I'm going to check the equation we found. We found it was y equals 5/2 times x minus 4. And as you can see, I have created a line that has and includes those 2 points. And that should do it.